Okay, we're going to write an algorithm to determine if a linked list has a cycle in it. So if we had 1, 2, 3, 4, and 5, and let's say it goes like this, 5 goes back to 3. So when, in this case, we have a cycle because it loops back on itself and there's no end with where next equals null. So, and another instance would be that a node can actually create its own cycle. So you could also have that kind of a situation. So what we're going to do is create a slow pointer and a fast pointer. And if at some point we're going to loop through, and if at some point they ever meet, then we know we have a cycle. So we go through and slow goes 1, fast goes 2, and then slow goes 1, fast goes 2, slow goes 1, fast goes 2, 1, 2. Now fast and slow are both at the 4 node. So we know that we have a cycle and we can return true. So to do this, we need to create our nodes. So we have and it keeps a node, which is next. And then we have our linked list. And it has a node and head. Okay, and then we can do public. It's going to return a Boolean. We'll call it has cycle. And it takes in a node. We'll just say it's an int, node events. And then that's our head. Okay. So we have our fast node. And then that's going to be equal to the head to start. And then we have our slow node, and that will also equal head to start. So while we'll want to make sure we have while slow is not null. And fast is not null. And fast.next is not null. Okay. We're going to do slow equals slow.next for 1 skip. Fast equals fast.next for 2 skips. And then if at any time slow equals fast, then we're going to return true. Otherwise, we'll be returning false. Okay, so let's go ahead and walk through this. So let's make a linked list with a cycle. I think first let's test it on one that does not have a cycle. So here's here's our head, 1, 2, 3, 4. Okay, so we have fast, we have slow, and then while slow does not equal null, and fast does not equal null, and fast.next does not equal null. So we're in that scenario, so we come in slow equals slow.next, so slow is there, and then fast equals fast.next.next, so here's our fast. Okay, and then if slow equals fast, which is not true, so then we go back, slow does not equal null, fast does not equal null, and fast.next does not equal null. So slow equals slow.next, fast equals fast.next.next, so now fast is here. And if slow equals fast, and that's not the case, so we go back around, and at this point, slow is not equal to null, fast is equal to null. So we go out of the while loop and we return false. Okay, so that looks like it's okay. And then now let's go ahead and test if it has a cycle within itself. So let's say the 4 just loops right back onto itself here. Oops. All right, so we go in, fast equals head. So here's our fast, here's our slow. While slow does not equal null, fast does not equal null, fast.next does not equal null. Okay, so slow equals slow.next. Fast equals fast.next.next. And if slow equals fast, which is false, go back around, slow does not equal null, fast does not equal null, fast.next does not equal null. So slow equals slow.next. Fast equals fast.next.next, so it goes to the 4, but the cycle loops around, so it goes back to the 4. So here's our fast. If slow equals fast, that's false, so we go back around. Slow does not equal null, fast does not equal null, fast.next does not equal null. So slow equals slow.next. So slow is now here at the 4. Fast equals fast.next.next, so it's going to go from the 4 back to the 4. So we'll just kind of leave it as is. And then if slow equals fast, which it does, then we return true. So it was able to catch that cycle just fine. Okay, and if we were to get a head that was null right off the bat, we wouldn't even go into our while loop. We would just immediately return false because slow would be initialized to that null, as would fast, so that that condition would fail. And this is it's pretty much an O of n solution because slow is going to go through each element one time, while fast goes twice as fast. So O of n, and it's no extra space.